I'll send you the group leader on Tuesday.
The broadcast is going, but I think you're a group leader for a whole week.
Hi.
Hi, Amanda. Can you hear us?
Yes.
Can you not? Okay, perfect. We'll see if David's coming here soon.
Okay.
Hey guys.
Hi.
Okay, Andrew, do you want to come for him? Okay, let's. You guys.
So just to let you guys know, I'm actually on the road right now.
Okay.
I had an emergency. I'm actually heading to California right now.
Oh, wow. Okay.
Oh.
Okay. Well, we'll get started so we don't have to take too much of your time up.
All right.
Alrighty. So, is everyone on part 2?
Yes.
No.
Well, besides David, I guess. Okay. Well, let's see. Did you already kind of do some of it, or Amanda, or?
Yeah, I did. The lesson 7 preparation.
Okay.
I did as well. I'll try to do it from memory.
Okay, perfect. So for the first number 4, what is the shape of the distribution? What did you guys find that?
Yes. I'm just opening up my document real quick.
Okay.
Okay, I put normal because it's normally distributed and it doesn't say otherwise. It doesn't.
Can you read the question for me so I remember what it was?
Yeah, it says the sample size n equals 4 was taken from normally distributed.
Yeah. I remember now. Yeah, that was normal. I got normal anyways.
Okay, perfect. And then the next one is very similar. It says the sample size n equals 40 was taken from normal distributed, which we got normal as well. Not only is it normally distributed, but the sample size is fairly large. So.
Yep.
Yeah, I agree.
Okay, number 6. The sample size n equals 4 is taken from a normally distributed 2011 cells data. What is the probability that the observed X is less than 40?
Okay, and then I think for that one I used the applet. Or no, I used the 68, 95, 99 rule and then got 0.1587.
I can't remember what I got. I'm sorry.
Sorry, what did you say you got, Amanda?
0.1587.
Okay, yeah. Sorry, I was looking at the wrong one, so I wanted to make sure. Yeah, that's what we got. Yeah, 0.1587.
Yes.
Perfect. Okay, number 7 is sample size. N equals 4 is taken from the normally distributed 2000 cells data. What is the probability that the observed value is greater than 35 and less than 55?
Okay, and then I got 0.9545.
Yes. Yep, that's what we got too. And then we got the same answer for number 8. Did you as well?
Well, I remember there were two answers that were the same, so I would assume that's it. I don't know.
Amanda, what did you get for number 8?
Yeah, number 7 and 8 were the same, 0.9545.
Okay, perfect. Awesome. Okay, so we'll go to number 9. It says sample size n equals 25 is taken from the normal 2011 cells. What is the probability that the observed value is greater than 50?
I got 5 over, oh wait, no, that was the z-score. Probability was 0.00621.
Okay, yep, that's what we got as well. Then we'll go on to number 10. Andrew, do you want to read it?
Sample size n equals 4 are taken from the right skewed 2010 phone sales data. What is the shape of the distribution of the X bar? So because it says right skewed in there, we put right skewed.
Yeah, same.
Perfect. Amanda, do you want to read number 11?
Yeah. Samples of size n equals 40 are taken from the right skewed 2010 phone sales data. What is the shape of the distribution of X? And I put normal because even though it's right skewed, the sample size is a lot bigger that time compared to number 10. And so using the central limit theorem, it would be normal.
Yeah, that's what we put as well. And then that you pretty much answered the next question. What is the theorem that justifies your answer for number 11? And you just central limit. So, yeah. And then number 13. Andrew, do you want to read that one?
A sample size n equals 4 is taken from the right skewed 2010 sales data, and you want to know the probability that the observed X bar is less than 35. Can you compute this probability using the normal probability applet with the information you have, and why? And we said no distribution is not normal.
So we
Right.
can't we can't compute it. No, we can't because the distribution is not normal.
Okay.
Right.
Is that what you got?
Yeah, I put the same thing.
Okay.
Yeah, I put it's not normal. And isn't the applet only used for normal distribution?
Yeah, yep.
Because it's the bell curve?
Yeah, because it's just exactly a bell curve, and I don't think it goes anywhere else. So, yes. Did we lose David?
I think so.
Okay, we'll keep going.
Okay.
A sample size n equals 36 is taken from the right skewed sales data. What is the probability that the observed X bar is greater than 36.5?
Okay, I got probability 0.9599.
Yep, that's what we got as well. And then you want to read the next one?
Yeah. A sample of size n equals 36 is taken from the right skewed 2010 phone sales data. What is the probability that the observed X is between 37.5 and 42.5?
We got 0.7887.
Okay, I think maybe I rounded differently. I got 0.7888. So
Okay, yeah.
pretty much the same thing.
Yeah, we just rounded. We probably maybe didn't even round. So. Okay, so let's move on to the quiz.
I have it open whenever you guys do.
Perfect. I thought I had mine open, but I think I might have closed it. Okay. Let me reopen it. Okay. I'm ready. Are you ready, Andrew? Okay, so let's go to number 3. Do you want to read that one, Andrew?
Use the normal probability applet to find the combined area under the standard normal curve that is to the right of Z equals 1.358 and to the left of the other Z-score. Round your answer to 3 decimal places.
Okay, so
1.358. So then we'd be doing the area of the left and right together. So we'd be shading in the right area and the left area, but leaving the middle area blank.
okay, yeah, I think that's what.
Is this less than 7?
Yeah, it is.
Yeah.
So did you get 0.175?
Yes. Well, yeah, rounded. 0.175.
Nope, I just put it in the wrong one though. Okay.
Okay. I'll read number 4.
Okay.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. Okay, so we're trying to find the probability that it's above or below the mean. So I guess we have to find the Z-score
Okay.
using that one equation.
Yeah. Where's that?
So Z equals X.
We have one over here.
So then 48 would be X, right? Because that's the sample.
Yeah. Okay. So I'm trying to remember. Z equals. What is that again?
Okay, it's Z equals X minus the mean, and then divided by what did they call it?
Oh,
The
the standard deviation.
Yeah, they called it something else though, but it's like the standard deviation symbol divided by the square root of n.
Oh, okay. Yeah. Okay.
Yeah.
So we have Z equals, and then the X would be
So
48.
Yeah, I'm pretty sure. But then for the mean, there's the first mean, but then they gave another mean, the sample mean.
I think the sample mean, so would it be 48 minus 177.6 over 26.7 divided by...
I can't remember what n was. Wait.
Oh, wait, here's the mean of the boat.
My notes. So.
You can't skip questions.
You can?
No, sorry.
Wait, the sample size is n. So X is...
Would X be 185?
Well, no, I think because I remember in the practice problems, like, the x was two numbers. Like, when you were trying to find greater than or less than, you were subtracting the numbers for x. I don't...
This commercial boat is 185 pounds. Previous value.
Or wait.
So we know standard deviation. The weights of a random sample of 48 commercial boat passengers were reported. The sample mean was determined to be 177.6 pounds. The sample mean is... And find probably the random sample.
I think I'm gonna look at that wedge player video real quick. Remember?
Well, we're only given 4 numbers.
Yeah.
So we know the standard deviation and we know the sample mean.
But they gave 2 means. There was the original mean and then the sample mean.
Okay, so when it says the sample mean was determined to be 177.6, would that be the mean of the means? So that's the mean of already their 185 pounds, right?
Okay, so x, right? I think Brittany already said it. So x would be 185. So 185 minus 177.6.
Yeah. Okay, there you go. And then 48 would probably be your...
Would be the square root.
The weight of a random sample of 48 commercial boat passengers were recorded. So, well, what's your N? What's the N stand for again?
The N is the sample size.
The sample size. The weight of a random sample of 48 commercial boat passengers were recorded. So that's your...
The random sample, yeah.
Is that your random sample? Yeah?
I think so. So let's plug that in. Let's see what we get.
Wow. We don't got calculator.
Well, no, but do this.
Where's my calculator? It doesn't. You know?
I don't. So I'll go
Okay, do these
85.
first.
Okay.
So write that down. It's where are the 48? 6.9282.
7.4.
And that will be divided by...
Well, you go 26 divided by... And you go
26 divided by...
26.7.
Divided by... 282. Okay, 3.85. Write as many as you can, because the more you get, the
I
more.
got it.
3.8538. Yeah, so that's good. Okay, so what's this? 185, right?
Yeah.
185 minus.
Did you guys get your z-score yet?
7.5.
Almost divided by
853. 8148. Okay.
Yeah. So we got 1.920.
Oh, my z-score was 13.303. Wait, so did you guys do 185 minus 177.6 on the
Yeah,
top?
and we got 7.4 for that.
Right, 7.4. And then you divided that by 26.7 divided by 48.
The square root
The
of 40.
square root of 48.
Oh, right. Okay. That's what I did wrong. Square root. Okay. So the square root of 48 is...
What was
It's
it?
it
It
was
was 6.9282.
Wait, the square root of 48?
Yeah.
Yeah.
You want to double check that just to make sure?
Yeah.
Yeah. At least that's what our calculator says.
Okay. Okay.
Do you have the applet up?
Okay, so it was 7.4 divided by 3.8539.
We just, yeah, 3.8538. 3.538.
So then, did you get 1.9201?
Yeah.
Yep.
Okay. That's better.
So then we'll plug that into the applet, right?
Yeah. Okay. 1. And then what we're trying to find is above or below the mean. So then we're just shading the right and the left and leaving the middle blank. Right?
Yes. Wait, are we putting this in the area or no, in the z-square?
In the z-score.
Let me get your
Because the equation we just did is to get the z-score.
Okay.
So then 1.9201 would be the z-score. And then to find the probability, that would be the area of shading the left and right. Because it's
Okay.
above or below the mean.
You have your applet, or you have yours up?
Okay, and were you able to find it?
Yeah, so I got 0.055.
Yep, perfect. That's what I got as well. Okay, so we'll go on to the next one. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? So the standard deviation of...
Which of the following will have?
I don't know.
9 observations are randomly drawn from a population. Distribution of individual objects. Which of the following will have?
So the sample size would be 9. But I almost feel like we can't determine it because there's not enough information.
That's what I'm thinking too. I mean, I know the standard deviation is small, but
we don't even have like the bigger population or the mean or...
the following will have a smaller...
The distribution of the sample.
It's smaller.
I think it's using.
Well,
I
if
think it's using the rule
the sample means would actually have
of more people would have
a
more.
larger standard deviation, right?
I think so.
Yeah, because it's saying the smaller the number, there's only 9.
Standard deviation.
The distribution.
I think it cannot be determined as well.
Yeah.
Okay, which of the following results implies that the spread of X bar decreases as sample size increases? Isn't that the central limit?
Wait.
Because as the larger the sample size, the spread.
So the X bar is the original mean. X bar is like the original mean, not the sample mean. So that decreases as the sample size increases. Yeah, so I'd say central limit theorem.
Okay. Do you want to read the next one, Amanda?
Yeah. Scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
So we're trying to find the z-score.
Yeah. So then we would do
160 minus 158 or 150.8
right.
divided by 8.8.
Well, wait a second. Because usually we have to do the standard deviation divided by the square root of n. But, so would that just already be the standard deviation we use?
I think, because I think this might be a review right here.
Okay.
Just because, remember last week or last time we didn't have to do the square root of n. That was just something new this week.
Right.
So I don't know. I could be wrong. But you want to type this in your calculator? 160 minus.
Okay, so I got 1.045.
Okay, let's see what 160 minus 150.8 divided by. You said 1.045.
0.045.
Okay, perfect. That's what we got as well. Okay, Andrew, do you want to read number 8?
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Round your answer to 3 decimal places. Example of the answer. Okay.
Didn't we just find that 160 and we have the z-score for it? So don't we just need to put it in the applet?
Yeah, so we just need to put 1.045 in the applet.
And then we want a score above that.
So then we're just shading to the right.
Which one am I shooting?
To the right.
Just the right?
Mm-hmm.
What's my number?
1.045. Did you get 0.148?
Yes.
Okay, so 0.148. Okay, perfect. So a random sample of 5 students was selected to take the GRE. Their scores were 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these student scores?
Okay, so we have to find...
Do we find the mean first?
Yeah, I think it wants us to find the mean on our own this time. So...
Do you want to add these up, Andrew? So 160, 175, 163, 149, and 153.
Okay,
Divided
so
by
mean
5.
is 160.
Yeah.
Okay. So then to find the z-score.
But we just found the z-score for that.
No,
No, that was the mean.
that's the mean.
So 160 is the mean.
Oh. Oh, okay.
Find the z-score, you go
And
160.
then the sample size would be 5.
So 155 divided by the standard deviation. Now we need to find the standard deviation of those numbers, right? So now we need to find
Yeah.
the standard deviation of those numbers. We'll use that other the PS.
Right? Is that what you're thinking too, Amanda? We need to find the standard deviation for them.
Yeah.
So if we go into, I think I don't know, we're going to go in and use the, what is it called? Is it this?
Yeah. That's good.
Oh yeah, the SPSS. Oh. Okay, so I'm going and type in these numbers. 60. Okay, so I have these numbers and I'm going to analyze them. I can't remember what to do next, Andrew. Do you remember?
Compare means. Okay.
Okay, so it looks like the standard deviation is going to be 10.50. 05,
Well, if you go, yeah.
I think.
Well, if you need to go to the third decimal point, then it's 50.
5 what?
050.
0,
5.
5. Okay. So
So then we're doing 160 divided by the 10.05 divided by the square root of 5?
Well,
Because would 5 be n because 5 is the sample size?
Yeah, you do 160 minus 5 divided by,
Wait, no.
because you're wanting to find the z-score, so you use that formula, which is your.
Right, but n is the sample size.
So is it x minus n?
No, it's x minus the mean, but x is like the original mean, and then the mu is the other mean. So I don't know what we're supposed to do about the means when we found our own mean.
yeah, but see, up at top it says the scores of quantitative portion of the GRE are approximately normally distributed with the mean of 150.8 and a standard deviation of 8.8. Use this information to answer questions 7 through 10. So we're only on 9. So
Oh. Okay,
so would it be 160 minus 158?
yeah, 160 minus 150.8.
Divided by 10.0.
Whoa, wait a second.
What?
And then 8.8 divided by...
So what you think it is? Ask her.
Okay, so I put 160 minus 150.8 divided by 10.05 divided by the square root of 5.
Wait. Yeah, 10.05 divided by square root of 5. Okay. So then would the z-score be 2.047? Is that what you...
Andrew's doing it right now.
Where's your phone? Okay.
So what did you get for that one?
For 9?
Yeah.
2.047.
Okay, 2.0.
Oh, okay, I wrote that down then. What?
4. Yeah, we have 2.047.
Okay.
Okay. So the next one, do you want to read that, Amanda?
Yeah, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So then we just put 2.047 in the applet.
Area?
And then just shade into the right only.
Do we put that in the area? Or
Yeah.
the Z?
Well, in the z-score.
Okay.
And what are you shading?
I don't know if we should shade just to the right or the right in the middle.
What's the question say?
It says,
What's the probability that 5 randomly selected students will have a mean score that is greater than achieved by the students in the previous problem? So, maybe just the right side. Selected students will have a mean score that is greater than the mean.
well, what was the other mean? Or what was the other one?
Than the mean achieved by the students in the previous problem.
So go back to the applet. Let's see it.
So if wanting to find out what's greater than the mean, students selected will have a mean score that is greater than the mean achieved by the students in the previous problem.
Oh yeah, I would just say that then. What's the area?
So then, I'm pretty sure we would just shade to the right.
Yeah, and what's the answer?
0.0.
0.02.
So
0.
0.020, right?
Yep. Okay, Andrew, do you want to read this next part?
Suppose the mean GPA of BYU students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of 81 students will be drawn. Use this information to answer problem 11 through 15. What is the shape of the sampling distribution of the sample variable, the x bar, which represents the sample mean of the 81 students who are selected?
I would say approximately normal, right? Because 81, that's a fairly big number.
Yeah. And then central limit theorem would say approximately normal.
So we're trying to find out. Let's see.
Sampling distribution in 81, is it? So, Amanda, do you want to read?
Which one talks about the shape? It's the
Central
limit theorem.
Central limit.
Okay, and that says approximately normal is the shape.
Yeah. Okay. Amanda, do you want to read 12?
Yes. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? So,
What's the mean of the distribution of the sample?
of the sample mean. So then,
What is the mean of the distribution of the sample mean? Sampling distribution of all possible samples. I'm stuck on this one.
Because they gave us, would it just be the regular mean, 3.5?
Yeah, could be.
What is the mean of the distribution of the sample?
Because, well, 3.5 would be the mean of the parent population.
It's correct.
3.5. Then they gave us the standard deviation and the sample size. How do we find a sample mean?
So yeah, and then the 13 says, what is the standard deviation of the sampling distribution of the random variable x bar, the mean of the 81 students who are selected? So is it just asking us the questions that are in the, asking us what are the things in 13 would be 0.7 and 12 would be 3.5?
Wait,
Well, what is the mean of
12.5, but then standard deviation of the sampling distribution, wouldn't that be 0.7 divided by the square root of 81? To find the deviation of the sampling distribution?
number 12?
13.
Oh, what is, say that again.
So the standard deviation they gave us is of the parent population. So then to find the standard deviation of the sampling distribution, would we do 0.7 divided by the square root of 81? To find that standard deviation?
I don't know. Yeah, we could try it. I mean, and see what we get with it. So we would take.
So then, square root of 81 is 9. So we just do 0.7 divided by 9.
Okay. So 0.7 divided by 9, I got 0.0778.
Yeah, so then we just put 0.078 since we're rounding to 3 decimal.
Oh, yes.
Okay.
Okay, so what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than
3.3.
3.3? So would we need to find the z-score of 3.3?
Yeah, so
3.3 minus 3.5, right?
wait, wouldn't it be, wait,
Divided by square root of 81. Do that.
Let's see. So that's what you said, 0.0778. And then that is 0.2.
Negative 0.2. Negative 0.2.
Is it, well, or did you get these right though?
Yeah, yeah, you do that, and then that's the standard mean. So, yeah. So, that's right.
So then would we do negative 0.2 divided by 0.078?
Yeah.
And you're wanting to know what? The right side.
So then the z-score would be negative 2.564, right?
Yep.
And am I doing this?
And yeah, the probability for that would be
Which one is it?
less than. No, less than. So the left hand. Good.
So then that's just 0.005.
Point 005.
Yep. 0.005. Okay. So what is the probability that the mean GPA for 81 randomly selected BYUI students will be greater than?
Wouldn't it just be 1 minus 0.005?
Yeah.
So 0. So 0.995?
0.995. Let me see. Okay, so we took.
I thought that was if you wanted to find out.
Would you do negative though? Would it be negative?
Wait, no, probability, I don't think probability is ever negative.
Okay. So yeah. Andrew, you're on the wrong one. This is 13. This is 14. So you don't even have 12. Okay. So would you go 1 minus? 1
Yeah,
minus
1 minus.
0.005? Yeah, okay. Yeah, I think you're right. Okay. Well, I don't know how good we did on this one. It was a little more tricky. I'm going to submit it. You got all yours, Andrew?
You do. I'll double check with you before you go.
Well, I'll go back. So you can see. Yeah, you can. Oh, we didn't do so hot.
What was that one?
What did we get wrong?
So we missed 5 and 6. So 5 is actually the distribution of the sample means. And 6 is, instead of the century limit link, it's the law. What? Central limit. What did I say?
You said century.
Century link. Sorry. Instead of the central limit, it's the law of large numbers.
Oh, because we just learned that one in this lesson.
So, don't switch that one. And then we got 9 wrong and 10 wrong, so we must have done something wrong there, but we got all the rest right.
9 random sample.
That's the one where we had to find the sample. I wonder if we did something wrong there.
Yeah, so because our mean was 160, then we did 160 minus 150.8, 9.2. Maybe 10 was the same as 7.
Maybe what?
Maybe 10 was the same as answer 7 because the
That's
mean
what
was
I'm
1.
wondering because it is 160. You know what? If you haven't submitted it, try it and see if it is that. You try it too, Andrew.
160.
Yeah, see if
From 10.
yeah, see if 10 and 7 are the same because we did right there.
4, 5. Oh, then
Sometimes
it's asking for the probability.
Did we give the z-score? Oh, one's the z-score and one's the probability.
So number 7 was the z-score, but then number 10 would be the probability.
So what if you put that in?
1.045 greater than 0.148. So then 10 would be 0.148 if it's going off of the z-score from 7.
Yes, I think so. Yeah, Andrew, put that in as a z-score. Okay, and then,
Oh, and the z-score.
yeah, into the z-score. Okay, and then what did you get for the probability? Oh, stop, sweetie.
I got 0.148.
Okay, let's try that, Andrew. Is that what you got?
Well, what am I doing? What am I
You're
doing?
putting this into the z-score.
What am I-
Oh, but what did you shade?
To the right, because it's greater than.
Oh, it is greater than, you're right, if you would have read it. But unshade that part, yeah. And then we'll enter.
Oh.
Oh, sweetie, go find your blankie.
0.148. Should be
Okay,
those
so,
answers then?
yeah, try that. 1.1148. Okay.
Where am I
Okay.
trying those at? 9?
Just, no, try it in 10. I don't know how to do 9 at all.
148.
Yeah. Okay. Well, hopefully that gives you guys a little bit of grade.
Yeah. So 7, we said 7 was the same as 9, and then 10 was 0.148.
7 is the same. Oh, 7 is the same as 9?
Yeah, because
Yeah, do that.
the 1
7
6 is what we got for the mean in 9.
Oh, that's right. That's right. That's right. Okay. Well, we'll see. Are you going to submit it, Andrew? Well, that helped a little bit. We still got 9 and 10 wrong.
Really?
Yeah, I don't know how to do it.
Oh, I got.
I don't. Sample of 5. Yeah, I don't know.
Okay, well, I guess better luck next time. Hopefully the homework's not this hard.
Yeah.
Well, okay, and then Tuesday, does that work for you?
Actually, I wanted to see if we could try meeting Monday and Tuesday next week instead of Tuesday and Thursday.
Oh, because it's Memorial Weekend.
Yeah, and my best friend's getting married, so I'm going to be traveling Wednesday through Saturday.
Okay. We have an FHE group that we meet with up here.
Okay.
And we don't get home. What time?
9.
Yeah, we don't get home until 9 our time, so it'd almost be 10 your time.
We'd be starting right now.
I don't mind it being late if you guys don't mind it, because I honestly stay up pretty late. So.
Okay, so let's plan on 10.
Okay.
If we get home earlier, we'll text you.
Okay.
Because we have your number. So maybe it could be even 9:30 or 10. We'll see what time next week. So yeah, we'll plan on that. Yeah, because you have basketball practice, huh? Any earlier.
Yeah.
Okay, so yeah, we'll let you know, and then we can email David too. He might still, I don't know, he might still be in California.
Okay.
Yeah, we didn't really get. And then we can meet Tuesday, same time?
Yes. So then Monday, 10 p.m. Mountain Standard Time, and then Tuesday, 9 p.m. Mountain Standard Time?
Yeah, does that work okay?
Yes.
Okay, perfect. If it's any earlier on Monday, we'll let you know.
Okay, and then, Andrew, did you want to be the group lead next week?
Yeah, I can do it.
Yeah.
Yeah, I guess so. I'll do it.
Okay. And then I'll do the next week after that.
Hey,
Okay.
can you say hi?
Okay.
Bye.
Okay. Okay, perfect. We'll plan on Monday then. Okay, love you.
Okay, sounds good.
Okay, talk to you later.
Okay, bye.
Bye.